Okay. So rotational equilibrium.
It's 17,640.
17,640. Unit?
Newtons.
Okay. It is RB plus.
It is a force, right?
Yeah. Resultant force due to B, resultant force on back wheel, front wheel, like that. Rotational equilibrium. So RB, the total distance from here, we have 1.8 minus 1.05. So 1.8 minus 1.05 plus RF, which is 1.05. It should be equals to 0. So here we'll get what? RB equals to 1.4 RF. Then we can substitute this value in equation number 1. Let's name it as equation number 1. So by this, if we substitute, we'll get what? RB as you said, 7350. And
RB is 10290.
RB is 10290. Okay. Then let's change this as RF. 10290 Newton. And half of it will give you for each wheel.
3675 and 5146.
Each wheel. 3675.
5145.
5145 Newton. Okay, so we studied force, and that is in translatory motion. Rotational, we studied torque. Now, same way, mass is, okay, in moment of inertia, analogy is mass in rotational. So it is moment of inertia. So I is moment of inertia. We'll denote with I. So I equals to moment of inertia into positional square of positional vector. Yeah. Summation, I can add here summation. Summation. And yes, it is independent of magnitude of angular velocity. It is not depending on angular velocity. It's just depending on axis of rotation. So like if I draw some random shape, okay, so it is depending on axis, at what axis it is rotated. This is point, like I'm taking up like point P. So it depends on like this velocity. No, it depends upon this rotational. And with this position, what is it? R. Let's take R as a positional vector. So this mass, which is at P, it depends upon axis of rotation, how it is rotated. At what angle, at what speed, whatever it is, we'll see that. At what it is rotated. So it depends only on axis of rotation. It is independent of angular velocity, that is omega. So for ith particle, V equals to Ri omega. So what is this kinetic energy? Half mv square. So for here, half, if I take first particle, m1 v1 square, and for ith particle, sum of all, like if we add
Yes, sir.
all, same manner what we did.
Many years.
Yeah.
Many years.
Now here v is also equals to r omega.
Sure.
So here v square means r square omega square. R ith for ith particle. Now I can write a summation form k equals to summation of I equals to 1 to n ki. Now if I substitute this value here, summation of I to 1 till nth particle, which is half mi ri square omega square. Now as we know, mi ri square is equals to what? Moment of inertia. So we can introduce here. I equals to 1 and which is I omega square. Or if I give a general form, half I omega square. That is kinetic energy. In translation, this is rotational motion. In translatory motion, what is it? Half. Yes. What is in translatory motion? This was in rotational motion, right? Half I omega square. And what is in translatory motion? Are you there, guys?
R omega square.
Nahi. Translative motion means standard what we derived formula, which in like work, power, energy, that one. That is a translative motion. That is mv square.
Oh, normal form.
So this is, see, translative motion means whatever we discussed. Rotational means whatever angular comes, that is in rotational motion, circular, angular, like that. Those things comes under rotational motion. Translatory means linear motion, whatever we derive for that. Okay. So I have a clear understanding of this translation and rotational. Okay. So there are some moment of inertia, standard moment of inertia, which I have showed you a photograph. Okay. So just I'll share you this as a PDF later. So, okay, let me ask you, is this do you have in syllabus like a derivation of those things?
Yes, sir.
Right.
Hollow sphere. Ring is mr square.
Yeah. You know derivation of those things like thin, uniform, hollow, solid, circular plate, hollow sphere. Do you know how to derive?
Derivation we don't know, sir, but we know like formulas.
Okay, it's not there for your syllabus. That's what I'm asking.
It's there, sir, but we didn't do like derivation part.
Okay, then I will show you 2, 3. Remaining is similar way. Fine. See, these are some like standard form which I have showed here. This I think so you already know, right? But see how it looks like this way. If you have seen, like hollow loop, hollow cylinder. It will be hollow. Is this photograph clear or shall I zoom it?
Clear.
Yes, sir.
Clear. It's clear.
It's clear, right? Okay. Solid sphere, long thin rod. How it looks like? Yeah, this you know. But most students get confused with the hollow cylinders
Yes.
and cylinder. Hollow cylinder, and like sphere. Most students get confused with this one. Okay. Are you reading each part? See, thin. If I start, this all the same formulas. I just showed you like a 2D and 3D diagram. That's it. No difference. MR square, thin loop means thin ring.
Mars square.
Yeah. Solid cylinder, hollow cylinder, uniform sphere, long rod, that is uniform rod, 1/2, sorry, 1/12 MR square, uniform rod with a length
3
L.
square.
Yeah. Okay, let me show you one or two. Then we can go to next part. So remainings are same, just same way we have to derive. So if I show you the first one, what was the first one? Thin ring, okay. Moment of inertia for a thin ring. So if you don't understand anything, you just ask me there itself, okay? For a thin ring. So ring, if I see, it's like circle. If I draw axis on it, if I show you side view will be like this, as you can see in that photograph also. Axis of rotation is this way. That means this is your momentum, sorry, velocity. Velocity direction is this way. Like, how can we say? It's clockwise. So radius, this is our radius. So if I take a piece of particle or a element, small element from this one, for that we will derive this. It will be same for all over because it's uniform actually. The ring will be uniform. So speed of each mass particle or mass element is v, which is v equals to r omega. So kinetic energy equals to half mv square, half r is r omega. Sorry, v is r square omega. Same. We are doing same thing. We are not doing anything new here. Same. Let's take this as equation number 1. If we required, we'll use it. Second equation also we know k equals to half I omega square. Let's take as equation number 2. So here, if we equate this, I'll get I equals to mr square. Simple. Are we doing anything like complicated? We got it for first one, mr square. Easy. Okay. What about Devanshika? Is she there? No. Okay. Then let's do about second one. Some rod. Okay. uniform rod. About what we are doing, perpendicular bisector. Let's take one rod. Center O. So this point, see what we're considering here, L by 2 and L by 2. Both points are considering half of length. Because it's uniform rod. So mass, as usual, consider a mass M, length L, axis, about axis A and B. We are finding moment of inertia about AB. What is it boring?
No, sir, it's fine.
Okay. Obviously, theory part will always be boring.
I don't know why people see everything as boring. So
Acha. Then it's good. Okay, so what we're doing, we are finding uniform rod, moment of inertia of this uniform rod through by the axis or perpendicular bisector, throughout the perpendicular bisector, which means in short our base is AB. Moment of inertia about AB. That is what we are going to do. So we can say here some points we can write, okay, consider and all that. We don't need to write that. I'm skipping it, that part. It is like continuous distribution of mass. Continuous distribution of mass. So what is continuous distribution of mass? Yeah, Ritvik? What do you mean by continuous distribution of mass? Varun? No idea? You guys can hear me, right?
Sir,
Acha. No, it's okay. You say no.
in all the
yes.
weight of the density
Yeah.
is same.
Okay.
All the what is
It's-
distribution?
Okay.
Same density, same point.
Exactly. In short, it is as usual name given uniform. Mass is distributed uniformly.
Uniformly, yes.
Okay. So when mass is distributed uniformly, so what we'll do? We cannot add it this way. So we have to integrate. Okay, so how we'll integrate? We need to form first formula, then we will integrate that formula. So we'll consider for integrating, we need to consider one strip, one small strip. Let's name it as dx with the thickness dx. That is, dx is
All strip.
small element. Yes, strip. Small element, small strip. So as it is mass distributed, so uniform length throughout the length, L by 2, L by 2. Mass per unit length.
Wall.
That is mass by length. So mass of small element was dx is m by L into dx. So moment of inertia of element dx. So that it is dx means small element, that means moment of inertia will be also small. So we'll take what? Di dm by x square. So dm, this was the dm, small mass. So dm is m by L.
to dx.
Yes. Now why we are doing this one actually? See, understand that we are finding mass of each element. So this is total length is L. Okay, row length is L. So if I want to find of each element, so how much number of mass? That is m. Total mass is m. So if I want to find for each element inside that, so what I'll do, mass per unit length. That will be your mass for smallest, like each element. dm will be your mass of each element. That's why we are dividing with the unit length. Mass per unit length, that is your dm. Same way we'll do for area if it is in 2D. If it is in 3D, we'll do with volume. This is 2D, just 1D, you can say, length only, not even 2D. Are you able to understand what I'm saying?
Yes, sir.
Okay. X square we have and dx. Sorry. So what are the limits? What will be the limits? So we need to integrate here. Integration of I di.
dx.
I'm sorry. Di. Then we'll write this value for di. But by the way, what will be the limit? We are integrating throughout length, right? So limit will be this one and this, L by 2 and minus L by 2, plus and minus. You know integration? Very good. Then start doing. Don't wait for me. Come on, tell me answer. Do it and tell me. M by L will be constant as usual. So we will integrate x square dx. So integration of x square dx will be yes, Varun?
2x
2
square.
2x square. Okay. What about the twig?
X.
2x.
Yeah, dx of x square you're talking, right?
I'm sorry, say again.
So you're talking about dx of x square.
Integration of x square, because this will be constant. M by L will be constant. Fine. Integrating minus L by 2 plus L by 2 x square dx. So integration of x square dx will be okay. Devanshika, is she there or still not there?
So is it x cubed by 3?
Yes, it should be x cubed by 3, because integration of x to power n, which is n plus
Plus
1
1
divided
by
by
n plus 1.
yeah. So m by L x cube by 3. Now we'll substitute limit L by 2 minus L by 2. So in place of x, we'll substitute L by 2. m by L cube by 2 cube into 3 minus of L cube by 2 cube into 3. Upper limit minus lower limit. You know this one, right? Do you know or not? Okay. Fine. So what you will get? Tell me. I equals to, tell me final form. This is 2 cube means 8. 8 and 8 3s are 24. So bottom denominator is 24. Here also 24. This is L cube. Minus plus. So 2L cube by 24 L 12.
1 by 12 L square.
Yeah. So M we have, L square we have, we are left with 12. So this is your final form. Now, if we find for circular plate, then what we'll do? Mass similar way. See, we did for area, sorry, length, because it was what rod. If you find for plate, then we'll take a strip like circular, like where's a photograph? Yeah. Like if I find for ring, then rod we saw. If I find for plate, circular plate, similar way we are going to do. We are not going to do. I'm just telling you. This circle. We'll take a strip of this one. Like this, we'll take a strip. Okay, that's what we'll find out. Circumference of this one will be your length. Your length will be circumference of this one. 2 pi r will be your length. Right? Then here
Yes.
we took for this mass for that as mass per unit length. Here we'll take mass per unit area. Clear? You can try this at some other time. And if you find for like a solid cylinder, we'll take mass per unit volume because it will comes under 3 dimensions. This is 2 dimensions, circles. If it is solid cylinder, it comes under 3 dimension. So we'll take mass per unit volume. Here 2 dimension, mass per unit area. That's it. So let's not waste time in deriving all that. Same way we have to derive. Can you do it?
Yes. Right.
Okay. So I hope you understood this one, or shall I explain this one again? How it derived? Yes?
Explain again.
Yeah. Okay, I'll explain again. So what we did here, there is a length. Okay, length of the rod, whatever L. Yeah, we took L here. So we are finding moment of inertia about its axis, AB. So as it is continuous distribution of mass, so we will integrate. So we are taking a small strip dx. So for that dx, we need to find out mass. So how will find mass? If we find for each element, that is mass per unit length. Like in short, what we are doing, unitary method. You know unitary method, right? Ritvik?
Sorry, I didn't get you.
Do you know unitary method? Like, do you know the unitary method? Like, if I give you easy example, like if I have 10 chocolates and 10 people, so I'll distribute each one 1-1. That is called unitary method. How can I
Okay.
divide if I have 20? So I have 10 people. So I'll divide it 2, 2, 2, 2. That is unitary method. So I have mass m. So if I want to find for each element, I'll divide by length, total length. I have total length is L,
Yeah.
total mass is m. So I'm dividing unitary method. So I got this for each mass, but how many I have? Dx I have. So I'm multiplying with each into dx. I don't know what is dx and I don't know what is each also. That's why we are multiplying. Sorry, we know m by L for each we know, but we don't know what can be dx. It can be 1, it can be 0.1, it can be whatever value, 0.001 also. So that's what we are doing it here. So now moment of inertia of that part, that is dx. So it will be small di, dm x square. So dm we found, dm is what? Mass of that dx element. So that is m by L x square dx. Now we will integrate this di. So integration of di and limits are whole. Like, see, whenever we integrate, we are integrating with this throughout. We will have limit. We have, see, when last class also we did some integration, I think so. So if we are doing finding for this one, we are finding limits from this point to this point. That is, let's name it as x and no, not x. We have C and D. We are moving our strip from C to D. That is our limit. If it is like this, AB, and we are taking a strip like this here, so we are moving our strip from this point, means lowest point, to the highest point, means A to B. We are moving our strip from A to B. So those end point and first point is your limit. So you understood how to find limits? Yeah? No?
Yeah.
Okay. Fine. So then we'll integrate as usual. So we know the formula, this one. So x to power n by, sorry, n plus 1 by n plus 1.
N plus 1. Yeah.
So if we integrate this one, it is square. So cube by 3. Then we'll substitute limits. Upper limit minus lower limit. Upper limit is this one. This is lower limit. So in lower limit, we already have minus. So minus minus will become plus. Then this remaining thing is mathematics. It's simple mathematics that I think you can know. You can understand that one, right? This cube and all that. 2 cube is 8. 8 3 is 24. So L cube by 24 plus L cube by 24, because minus and minus will be, see, minus L cube. That means if it is square, then it will become plus. But if it is minus,
If it's odd, it will
Minus.
become minus. Yeah.
Sir.
exactly, minus L into minus L into minus L, it will be minus L cube. Yeah. So it will be twice of this one. So I'll get twice of L cube by 24, which is 1 by 12. We already have M and L at bottom. So L M by L
And then
into
limit answer.
12 square. So we have this form, ml square by 12. And as we did this for length, so that's why unit lengths. And if we find for some circular ring, or sorry, circular disc, it is 2 dimensions, so per area. If we find for solid cylinder or hollow cylinder, it will be for mass per unit. What will you use?
Solid.
For plate,
Mass by-
mass per unit area.
Yeah.
for hollow.
Mass by unit volume.
Yes. Same thing. We have remaining steps same, just small change, that is for unitary method. Volume. Because it's volume. Cylinder comes under volume part. Plate comes under area part. It's 2D. That's why. Okay, so no need to derive remaining. It's similar way we can do it. Sphere also same, like 4/3, you know, volume of that, right? You can do that. Do you want me to derive remaining, or we can go to next part?
Next part.
Next part.
Okay. But this derivation you should know, because suppose sometimes if you forget, so that you can derive and tell, can get the formula. Yeah. And how to derive, if you know concept, then you can derive easily. Okay, so overall, whatever we saw, let's sum up. Our moment of inertia, whatever we saw. We wrote some point here, we saw here, what are the formulas we got. Let's sum up that form. Let's sum up. Okay. So some points about moment of inertia. It is a mass of body, and it shows shape and size. Again, it shows position and orientation. About its axis of rotation. Wait, I wrote rotation. Rotation. So distribution of mass is about its axis of rotation. Okay. Let's go with kinematics of rotation. Then we can end this chapter. It's very small then. Only kinematics we have left with. You have full syllabus for your exam, right? You said me that day. Yeah. Arun?
Yes, sir.
No, you.
We have full syllabus.
Right, yeah. Okay. Kinematics of rotational motion. So you know what is kinematic, right? Kinematics deals with what? What is kinematic?
It's with acceleration velocity.
Yeah. In short, motion. Study of motion.
Rotation is angle. So angle of moment, angle of acceleration, angle of
Yes.
velocity.
Exactly. Study of motion without how it is happening. That is kinematics. So what are the formulas we know in kinematics? Like laws of motion you study, right?
Sure.
V equals to
Wait.
U plus
Plus
80.
AD. Square minus
And
square equals to AS.
S equals, yeah, that also V square
minus
equals to u square plus 2as. What about this third one? Second one?
half s is equals to half ut plus half at
Yeah. Initial plus ut plus
plus half at
of at square. Here generally in till now we are taking 0.
Yes, sir.
If we require, we will use it. That's what. That is. Even we can say in this rotational motion, same form. Like same. Tell me same formula. This convert is in angular.
Omega is equals to omega naught plus
Alpha t.
Yes, sir.
Alpha means angular velocity.
Angular velocity.
So distance we have theta. Theta naught plus
Plus omega
omega naught t
t
plus
plus half alpha t.
t. V square omega
Omega
square.
square is equal to omega naught square plus 2 alpha.
Now distance will take as s minus s
means
naught.
S.
So here theta minus theta naught. So don't get confused with extra thetas here. Okay. Same formula. We are considering here till now we are considering 0.
0.
But
Sir.
I'm just including here. That's it. Now what is dynamics? See, kinematics was study of motion without considering how it is happening. Okay, without considering how it is happening. Dynamic is what
Like
with
action
considered.
of forces.
Exactly. How it is happening. Who is moving it? Force, torque, like that. Those study comes under dynamics. So if I just conclude this one statement, like study of cause of motion. In short, force and torque. Translatory motion or translation and rotational. So displacement was S or X here, rotational. Angular displacement.
Displacement. Yes.
We have omega. Velocity V.
Angular
Here,
velocity.
angular velocity.
Angular acceleration.
Here I wrote wrong. It is theta. Yes. Acceleration A.
Angular acceleration.
Angular acceleration, which is
L.
alpha. See, I'm just summing up all the formulas here, so that like you won't get confused. Mass M, moment of inertia, which is denoted by I. Force F equals to ma. Here torque.
R into F.
Yes. I alpha. I alpha. So work done will be force into displacement. Here work done will be torque into
theta.
Theta or d theta. We'll see that. We didn't derive this one. We'll derive.
Yeah.
So kinetic energy we saw half
mv square.
Here
Half m half r omega ir.
I omega square. R नहीं, omega. So power formula P equals to
Work done by time.
yes, or force
Force
into
into
velocity. You know this one also, right?
Sure.
Work done by time. So force into displacement. So displacement time is velocity. Yeah. So for this one rotational, power will be force will be tau,
tau into
velocity will be
omega.
omega. See, units will be same.
Sure. Sir, I can't hear you.
Yeah, linear momentum will be P equals to
Equals to
mb,
mb.
and this one angular momentum
I again I into
angular momentum L equals to
I into
m is I into omega.
omega.
Is this thing clear?
Sure.
Okay. Now, let's see conservation of momentum. Yeah, angular momentum.
Conservation is total momentum, it remains same.
Exactly. That's what. So L equals to I omega.
omega.
Here, I omega will be constant because
Yes.
its conservation
Conservation.
will be constant. Now, suppose example we can say you know that swirling chair, right? Revolving chair.
Sure.
Now, if you observe, if you're sitting like holding your hand and like someone is rotating you, and same way, if you are just expanding your hand outside like like a hand span, if you're expanding like a hand span more, and someone is rotating, you'll feel the difference.
Yes.
Have you observed that?
Yes, sir.
So what is the difference? Is it more or it reduced? Moment of inertia is reduced?
I think it's reduced.
Yes. Because your mass is now distributed over the
Yes, sir.
longer span, right?
Yes, sir.
Moment of inertia decreases. Decreases because mass is distributed.
Repeated.
And to the axis. So we can say L equals to I omega, which is equals to
constant.
yes. Let's see some rolling motion. Then we can Okay, we don't have time now for numerical. Okay, let me just give one question. You can try it as a homework.
Okay, sir.
Just same formula. Okay. From the chart, you can use a formula. Have you taken screenshot or like you have already? I think so. It will be there in your book, right? Textbook.
Yes, sir. Yeah.
Yeah.
Class, we are class also.
Okay, fine. So use the textbook formula, and I'll give you one question. You try it. Because then you have to study for your exam also. What's your tomorrow exam?
No, sir. You have 2 days time. So I'm free.
What is the next exam then?
Maths 1B.
What is it? Sorry?
1B. Maths 1B.
Acha, maths 1B. Okay.
Yeah, today was 1A.
Okay. How was it today?
Very easy, sir. Yeah,
Okay,
it's
what do you have in
matrices.
1B and 1? Like, what's the difference? What do you have in that?
In that we have like geometry and differentiation. And also
Okay,
calculus.
calculus
Yeah.
part.
Yes, sir. Calculus part.
Okay.
In 1A trigonometry, like proper
That is your
triangle.
1B.
Vectors.
1B is calculus part.
Yes, sir. And geometry.
And 1A is remaining.
Trigonometry and that vectors.
Okay. That means 1B is interesting. I like calculus.
And also it's hard.
Is it
Little
hard?
bit tough. Yeah, it's a little bit tough than 1A.
Acha.
Because big questions like equation and differentiation also.
Oh,
There are like tangents and normals, maximum, minimum. So,
yeah, those things is like good. It's
yeah,
interesting actually. You have to
it's
think
very
so much.
important. Yeah. 1A is easy, but I'm getting scared in 1B only. I'll get less in that.
Okay. Then what is the next exam after that?
After that, we again classes start. Like they'll complete the portion. Then they'll do that IP revision in 2 months. After 2 months, we'll exam it.
Okay.
Main exam. Yeah, weekly we have like mains in advance also. 300 marks. We should write November.
Okay. So after this, what you're planning? Like after 12,
Usually-
like you're planning anything to give some competitive exam or something?
Yes, sir. MSET and the mains also.
Okay.
Mostly MSET because mains is a little bit tougher. So IP is easy. To get MSET, we can go any like so many colleges are there. Mains is very like we don't have that much. We get more marks.
And give both.
Now is it? Yeah.
So we'll have more option.
Yeah. If I get mains also, I will go to like NIT.
Yeah.
Actually, my brother is in VIT now. He's studying.
Oh.
My brother got like MSET 846.
Oh, that's good.
Mains he qualified, but advance gone. NIT he got, but he took VIT, Vellore, because he needs like computer science. He wanted to do computer science.
And what do you plan?
Same, sir.
Computer science.
Yeah. I like coding also.
Good. It's interesting part actually.
Yes, sir. Like electrical is there, but electrical is a little bit tougher. They said.
Okay, just question over.
Or I'll take screenshots, sir.
Yeah, no problem. 1 second, I didn't finish. Cylinder. So momentum of inertia, moment of inertia for cylinder they're asking, right? So you know formula.
Yes, sir.
1/2 r square
MR square.
about its axis. Now you can take a
Student will get
screenshot.
it. Yeah.
Yeah, it's very easy. Then use kinetic energy formula half I omega square.
Square. Yes, sir.
Then still angular momentum. So L equals to I omega.
I omega.
That's it. Nothing else.
So yes, sir.
Okay.
Physics is my favorite subject mostly. always. I don't like